Have you ever noticed how your brain instinctively tunes into the most important parts of a conversation, filtering out background noise and irrelevant details? This incredible ability to focus, to weigh what matters most, is something we want to replicate in artificial intelligence, especially in understanding complex data like language. In the self-attention mechanism, query, key, and value are three fundamental vector representations that empower a model to dynamically weigh and prioritize different parts of its input. They allow the model to determine how much attention each word or element should pay to every other word or element, effectively creating a rich, context-aware understanding of the entire sequence. The core idea behind these three vectors is to model a search and retrieval process. Imagine the query vector as your specific question, the key vectors as a collection of labels or indexes for available information, and the value vectors as the actual content associated with those labels. When a query is compared against all keys, it identifies which pieces of information are most relevant to the current question. This relevance is typically calculated using a dot product, which measures the similarity between the query and each key. The higher the similarity, the more relevant that particular key, and thus its associated value, is to the query. To put this into practice, for each word or token in an input sequence, the self-attention mechanism generates a query, a key, and a value vector. Let us say you are processing the word bank in a sentence. Its query vector will be compared to the key vectors of every other word in the sentence, for example, river and money. If bank is a query about a financial institution, its similarity to the key for money will be high, and its similarity to the key for river will be low. The resulting similarity scores are then scaled and passed through a softmax function to generate attention weights. These weights quantify how much focus the current word, acting as the query, should place on each of the other words in the sequence. These attention weights are crucial because they are then multiplied by the value vectors of all other words. This means that words deemed more relevant by the query key comparison contribute more significantly to the final, context-rich representation of the current word. This process, often referred to as weighted sum of values, generates an output vector that encapsulates information not just from the current word, but also from all other words in the input sequence, selectively amplified by their computed relevance. This sophisticated interaction allows transformer models to capture long-range dependencies and subtle contextual nuances that were challenging for previous architectures. Ultimately, the interplay of query, key, and value vectors provides the self-attention mechanism with an elegant and powerful way to build highly contextualized representations of data. By acting as a sophisticated internal search engine, they enable the model to selectively gather information from across the entire input, ensuring that each part of the output is informed by the most relevant contextual clues, leading to significantly improved performance in tasks like machine translation and text generation.